Hi, good evening, everyone. In the last video that we did, we were discussing about what is utility. We went ahead and we discussed about what is convexity, what is a convex set, and how can we go ahead and how can we interpret the different properties of indifference curve mathematically and economically. There was a short assignment that I gave you. You can go through that assignment once. I've also posted the solutions. In case you have any doubt, we can go ahead and take those doubts also. We can take it either after the class today or you can post it in the group also. Now, let's go ahead and understand how can we use the concept of utility mathematically. See, let us begin with the first kind of utility function, and these are known as the well-defined preferences. So you call them as your well-defined preferences. Okay. Now, what are well-defined preferences? See, we studied some of the very important properties related to indifference curve. One of which was it should be downward sloping. Secondly, it should be convex. Third, it should also go ahead and follow monotonicity. Higher the indifference curve, more should be the utility, and so on. These were some of the properties that we studied. When we go ahead and we find an indifference curve mathematically, which satisfies all such properties, it is known as a well-defined indifference curve or well-defined preferences. Now, a well-defined preference usually has a utility form which looks like this. Uxy is equal to x to the power alpha, y to the power beta. Whenever you will see this form of preferences, they will be known as well-defined preferences. Now, here I would be deviating for a second and I will be going ahead and telling you about a method. You will be doing that in maths also, but at a very high stage later on. But we would be using in microeconomics from the very first day. So we want to cover it today itself. And this is known as the Lagrangian method. Now, what is a Lagrange method? See, whenever you have to maximize or minimize anything that is subject to a certain constraint, you can go ahead and use Lagrange. Let's take an example. For example, whenever you want to go ahead and maximize your utility subject to your budget constraint, right? Or whenever you want to maximize your production function, the output that you produce, subject to your cost. Or whenever you want to minimize your cost, subject to a given level of output. So subject to your production function, simply. Whenever you have to maximize or minimize any function that you subject to a constraint, the method that we can go ahead and use is known as a Lagrange method. my entire microeconomics course that I will do with you will use this Lagrange method in huge details. We should be using it throughout our course. Whether I'm going to talk about consumer function, production side, monopoly side, whether I'm going to talk about general equilibrium, risk, intertemporal, anything that I do in microeconomics is going to make use of this Lagrange. Now, let's understand how do we set a Lagrangian function. So I'm going to go ahead and take the utility function. So let's say that I have a utility function u of xy, and this is x to the power alpha, y to the power beta. And let's say that there is a budget constraint. Budget constraint is my usual budget line. And my budget line just says that the expenditure that I do, total expenses that I do, cannot exceed my income. So it has to be either less than my income or equal to my income. But since we are maximizing our utility, we don't have the scope of using less than the income. We would always be using our entire income. This is something that will always happen. We will not go ahead and choose any bundle which uses less than what our income is. Now, if I talk about what is the expenditure that we do on good X, simple. Let the price of good X be Px. Let us go ahead and buy X units of good X. So the expenditure that I will be doing is X into Px. Sorry. Where I am buying X units, each at price Px. It is like saying that suppose I buy 10 units of good X, and each unit I buy at a price of 20, I am spending 200 rupees on good X. This is my expense on good X. Similarly, Y units I am buying of good Y at the rate each unit at price Py. So I am spending Y into Py on good Y. So I'm spending X into Px on good X. I'm spending Y into Py on good Y. What is my total expenditure that I'm doing? Well, I am spending X Px into X, Y Py into good Y. This is my total expense that I'm doing on two commodities, and this is equal to my income. I can also plot my budget line simply. So when I talk about good X, here I'm x-axis, this is I'm taking good X. Y-axis, I'm taking good Y. When I talk about x-axis, my consumption of good Y is 0. I'm only consuming good X. So what do I do? How do I find the intercept on the x-axis? I say X into Px plus Y into Py is M. On the x-axis, your Y is 0. So you will get X into Px is equal to M. So your X will be M by Px. So this will be my intercept on the x-axis. On y-axis, my X will be 0. So Y Py will be M. So my Y will be M by Py. This will be my intercept on the y-axis. I will join this intercepts and I will get my budget line. This is my budget line. The slope of this budget line will be perpendicular by base. So M by Py upon M by Px, which will be Px by Py. Since budget line is downward sloping, I will have a negative sign. These are some of the important chunks of budget line. The slope is Px by Py. Intercept on the x-axis is m by px. Intercept on the y-axis is m by py. And the aim is to go ahead and maximize your utility function. You're getting your utility from two commodities, good x and good y. And this is a well-defined utility function. Right? This budget line part is something which is chapter 2 of your intermediate micro also. Okay. Now, I know what the equation of my budget line is. I know I have to maximize my utility. How do I form a constraint of it, and how do I form a Lagrange function? To form a Lagrange function, the general technique is to write L. You write whatever your objective function is here. Whatever you want to maximize or minimize here. Plus, you write a lambda here. This lambda is called Lagrange multiplier. And here you write your constraint. And the Lagrange is formed. Whenever you are writing this constraint, you will always write constraint in form of RHS minus LHS. That's the usual way of writing the Lagrange. This is step 1. Step 2. Whenever you will form a Lagrange,